It's 10:32. Why does it feel like it's 11:32? Weird. Weird. It just feels weird. Okay. Well, hello everyone. How is everyone doing? I graded your test. You guys do not like to round. Not good. You do not like to round. Finally. Sorry, Haley. Took too long. I was getting all ready. I had to find my notes. I couldn't find my notes. Well, we only have what? We only have 3 weeks left, and then that's it. 3 weeks. So we gotta chop. So we gotta do 6 for today, and then we're gonna start 7. No, 7's easy. So I'll have to show you 6-4 first. 6-4 is a little bit challenging, but we'll get there. I'll send you guys the your graded exams later today, like this evening. I'll send you all your graded tests. Yeah, you're rounding this. No bueno. No bueno. You will redeem yourself on the next test, right? Of course. Okay, so we were talking about the central limit theorem, and we were talking about, when were we talking about cappuccino? When were we talking about that new coffee drink that they were planning on serving at that, I don't know what place they used. It wasn't Starbucks. What was it? What was the place that you all were talking about, that coffee place? It wasn't Valero. Valero. No. But anyways, that theorem, the way it works is that you have multiple samples. You have more than one sample that you're conducting, and you're applying this theorem. And I think we went over the theorem, or we went over it in easy terms to understand, right? But one of the requirements for that is that the problem has to state somewhere that the distribution is normal, and your n, the number of samples, has to be 30 or more. Now, it doesn't necessarily have to have both of them, both of the requirements. If this number 2 isn't met, okay? If number 2 is not met, it has to at least say that part. It's got to say that. So you'll see that in a little bit, that this rule doesn't always apply, but you'll have to understand why. Why does this matter? Why does this matter too? So the steps are going to be similar to what we did in 6.2. So the only difference is that you're going to have to read the problems carefully, right? And so if you have multiple samples, I'm going to show you my little paper. Does anyone need this paper? I can send it to y'all again. That was the chapter 6. Does anyone need it? I can send it through the chat again in case you did not. You don't have it here. Let me send it. Let me send it to y'all again one more time. I have it here somewhere. Where's that? This is taking forever. No, I don't have it. Great. Just great. I thought I had it. I had it somewhere. I don't know what I did with it. No, I don't have it. No. Okay. Well, it's on our modules. Go to modules. It's in our modules. Go to modules. Scroll down to course resources. Should be notes, stat disk. chapter 6. It's the very last page. I think it's page 4. The very last page. All right. So let me tell you how this is going to be. It's going to be the same thing that we did last time, folks. Same thing. So on my notes, I have two. There should be a column like that. Should be 2 columns. So because if we do one sample, we do what we did in 6.2 and 6.2. Remember we identified the mean and the standard deviation, right? And we wrote down the probability statement with the P, right? The parentheses, the P, blah, blah, blah. And then we converted, and then we found the area, right? So we did that on 6.2. On 6.4, you will notice that you will have more than one item. 2, 3, 4, 5, whatever it is. You're sampling more than one item. That the amount of items that you're sampling is going to represent your N. N is going to represent the total number of samples. Okay. And so I didn't mention about the theorem. So pretty much the theorem says this. So we got to find the mean, right? So remember the notation for mean. The mean of the means is mu x bar. That's what the average of the means is. So the theorem goes like this. If you have a whole bunch of samples, the mean is not really going to change from what it is when it's a one sample. It's pretty much the same. So whatever your mean is given, that's what your average of your mean is going to be using. We're going to use that as its base. However, when you all find the average of all the standard deviations, this one's going to be a little bit different. It's subscript. It's mu subscript x bar. So to find it, what you do is you get your standard deviation and you divide it by the square root of the total number of samples. So you guys are going to have to find in your calculator, this is going to be the critical part. You got to find the square root button in your calculator. Does everyone know where your square root button is in your calculator? Very important. You know where it's at? It's right there. See it? Right there. Right there. See it? Right there. You're not looking down. Look down. Look, you're looking up. It's about you're looking up.
Trying to find lost it.
Oh,
I know where it's at. I know where it's at.
You were looking up like, wow, you got a calculator up in the ceiling? Dang. Wow, that's virtual. On mine, I have to, this is what I have to do. On my TI-30XS, let's see if I can zoom it in. I have to hit the green second key, and it's right here next to the 7 right there. There's the little square root. That's how I get my square root. Second, and that button right there. You can barely see it. It's like lime green, but it's a little square root button. Second, that. On the graphing one, I believe I have to hit second, and right there, the x squared button right there. Second, x squared. And that should give you my square root. You don't want a cube. You don't want the cube root. You just want a square root. So that's what you want to find. That's the most important thing, or the difficult thing about this section, is finding the square root key. So you will have to compute that. You'll have to divide whatever the standard deviation is. You're going to divide it by the square root of n. And we don't want you to round. Do not round that number at all. Just do not round it. Leave it all the digits behind it. Just don't. If you cut it off anywhere, your answer is going to come out way off. So don't round your sample, or I guess your mean, your standard, your means of the standard deviations. That's what that is. Mean standard deviations. And you do the same process, right? So when we did one sample, you guys remember that when we did real life, what variable did we use in our probability statement when we dealt with a real life situation? You all remember what it was? It was a variable. What was it? It's a variable that I use in conjunction with the inequality greater than, less than. But there was a letter that I put there before I converted it. Do you remember what it was? It was X, right? No crying. Over here, when we're sampling more than one item, our probability statement is not going to have an X, not only just the X, but it's going to have an X bar. You'll see, I have to show you on a problem. Why is it that we use X bar when we're dealing with a more than one sample? So you're gonna have to use this, folks. You're gonna have to use these two columns to decide which one do you do. Do you do the one sample or you do the multiple samples? One or the other, right? And of course, you guys are gonna do the conversion. The formula is pretty much the same. I'm gonna just tell you that you don't have, if you don't want to learn anything new, it's pretty much the same formula. It looks kind of freaky, but it's the same. I'll show you in a minute how it's the same. But when you plug them in, you're going to use that number and that number here and there. Just like this one, you use the mu and the sigma there and there, right? Plug in those numbers. This number that goes there will be that side number that is connected with the X bar. Remember, the X was this number that was connected with that, right? That's where that number goes. All right, so we're gonna do one. So I'll show you. It's gonna take about 3 problems for you to digest it. So just to show y'all how it works. All right. So you got your two sides, right? All right, we're gonna go to page, I forgot what page. I think it was 212. I think it was 212. I think it was 212. All right, so I'm gonna read it to y'all. You decide, am I gonna do the left side steps or the right side steps? Okay. I'm gonna go to page 212, I think. No, it was 272. I was way off. Page 272. We will do number 5. Okay. Page 272, number 5. Zoom it in. All right. Okay, here we go. Number 5. In exercises 5 through 8, assume that the females have pulse rates that are normally distributed with a mean of 74.0 beats per minute and a standard deviation of 12.5 beats per minute. All right, just by me reading that statement above number 5, can anyone tell me what is your mean and your standard deviation?
Your mean is 74.0.
Yes.
And your standard deviation is 12.5 beats per minute.
All right, man, let me ask you this. Where did you get those numbers from?
Where you just read?
Oh, that's right. That is exactly right. Very good. Very good. Excellent. All right, excellent. Okay, now let's do number 5. It says, if one adult female is randomly selected, find the probability that her pulse rate is less than 80 beats per minute. Okay, just by me reading that statement, how many samples are conducted in number 5? Is it one or multiple?
1,
Why is it one?
because it says if one adult female.
Excellent. Dab. That's correct. It is one, which means that I'm going to go through the left side of the handout on page 4 of my notes, which I'm trying to find and I can't seem to load it up. There we go. I'm going to go through this process of what we did in 6.2. I already did the mu, I already found the sigma. Now I have to find the probability. All right, so I'm gonna put probability of X is what? Let's go back to the problem and you tell me the inequality symbol and the number that goes next to the X. What? Your inequality symbol? Is it less than, greater than, or is it in between?
Less than.
Very good. Look, it says less than. Very good. Less than. And then what number do I put after the less than?
80 beats.
80 beats. Do you like to eat beets?
No.
Oh man, did you know if you eat beets, it makes in the red beets, when you go to the bathroom, it looks like you have a urine infection? Freak out. My wife freaked out because we were eating beets, right? And said, oh no, I think I have a urine infection. What are you talking about? My pee is red. No, ma'am, it's the beets. Yeah, don't panic. It's all good. All right. So do you guys understand just by number 5 why the probability is written like this? P parentheses X is less than 80. Does that make sense? Because I think it said less than. So now I'm going to convert. All right, so I'm going to use my old faithful formula, Z equals X minus mu over sigma, right? And I'm going to plug in my numbers. So the X value is the 80, right? 80 minus my mu, which is the 74.0, and I'm going to divide it by 12.5. Shoot, I forgot to put the stat disk up. We'll do it in a minute. All right, so I'm going to calculate this in my calculator. We're not using the square root button yet, folks, not yet. I'm going to put that in my calculator. Parentheses 80. Okay, something's going on with my calculator. What the heck? I think my calculator broke. What the heck happened? Hold on, I'm having technical issues with my solar calculator. Memory cleared. I wish we could do that with our brains. All right, hold on. There you go. 80 minus 74.0. 12.5. 0.48. Okay, I don't have to round this one to 2 places. This is good. It's already 2 places. So I'm going to write my probability as z is less than, I'm going to put this number 0.48. It's less than, so I'm going to look at the left area. When I type it into StatDisk, I'm looking at the left area. Less is left, right? Less is left. I'm going to put that, I'm going to put this number in StatDisk. And let's see what we get. Wait, I don't think I put StatDisk up. Nope. Analysis, probability distribution, normal. There you go. And I'm putting 0.48, not O. I don't think it's gonna like the O. 0.48. And left, there it is. I need 4 numbers behind the decimal. So that number is 0.6844. 68.44%. Is it 272? $68.44. Yep. That's exactly what the answer in the back of the book. I have the answers. I am good. So this is pretty much what we did on 6.2 with the word problems. Nothing changed. Kind of like a good review of what we did in 6.2. So boom, that's part A. Now, part B, on the other hand, is going to be different. How so? Let's see. Let's look at part B. You tell me what makes it different than part A, other than the letters. Okay. Here's part B. I'm going to read it to you. If 16 adult females are randomly selected, find the probability that they have pulse rates with a mean less than 80 beats per minute. Okay. How many samples are they doing on part B? Is it 1 or is it multiple samples?
Multiple.
Yes, that's right. So what is your N for letter B? How many samples are they conducting?
16.
16. All right. So you're doing multiple samples, which is 16, which means that I'm going to have to use the other side of my handout to work. I'm doing more than one item. So there's my N. You told me it was 16. Now I have to find these 2 numbers. All right, so I'm gonna transfer the formulas to my paper. And so I want to find mu x bar. Okay. Now mu x bar is going to be our original mean. What was my original mean for problem number 5? What was it?
74.0.
74.0. We're going to use the same mean. We always use the same mean. But when we calculate the average of the standard deviations, I am going to use this formula. Sigma over the square root of n. Now, the sigma is going to be your original standard deviation that we used, which is your 12.5. And we're going to divide it by the square root of n. My n was 16. Right? And so we're going to calculate that on my calculator or your calculator. All right, so let's compare. Let's see. What did you guys get if you divide 12.5 by the square root of 16?
Four.
You got 4? Oh, square root of 16, yes, it's 4. So now divide 4 into 12.5. $3.125. You were correct, Madam. 3.125. Yes, so you all can do it in parts. You wanna do the square root first? Go for it. Do the square root first. Whatever answer you get, you're gonna go ahead and divide the top number by whatever you get for the square root, and then calculate it. Or you can do it in one halasso. I was able to do it in one on the same line. I did 12.5 divided by square root of 16. I just did it all at once. Okay. And now I gotta go back to my problem. And you're gonna tell me the, oh, actually, the reason, you'll see why in a minute. So now I gotta write my probability statement. And I'm not gonna use X anymore, I'm gonna use X bar. Why do I use X bar? Well, go back to our problem for part B. I'm gonna show y'all. For part B, it says if 16 adult females are randomly selected, find the probability that they have pulse rates with a mean. You see it says mean on there? Mean is what? What inequality symbol am I going to use next to the X bar? Yes, someone said less than 80. Because this says mean less than 80, right? 80 beats per minute. So look at my paper. You can see the difference between part A and the part B. Part A was just X. Part B is X bar. Because it says mean. The problem says find the probability that the mean pulse rates are less than 80. I don't think I'm gonna have space. But anyways, let's see. We gotta convert. Okay, so when you convert, you're still gonna use that as your X. So that's 80 minus your mean, 74.0. But this time we're gonna divide by what? What do we divide by? I gotta divide by my new standard deviation of 3.125, and not 1,000. 3.125. I ran out of space. Sorry. Okay, so I'm gonna calculate it. There's my mean, there's my new standard deviation. I'm gonna divide subtract 80 minus 74.0 divided by 3.125. Tell me what you got.
1.92.
Yeah. 1.92. That's exactly what I got. So now we're gonna find the probability that our Z is less than 1.92. I know less than means left area. And so I'm gonna go in and plug in 1.92 into StatDisk and find the left area. No yawning. Someone's yawning. Who is yawning? They just 1.92. Left area. I need 4 digits behind. So my answer ends up being 0.9726. Or you can write it as a percentage, 97.26%. You guys can check the answer in the back of the book. If you don't believe me, check it out. I think that's what the answer is for part B. 97.26. So you'll be doing one sample, first part. Multiple samples, second part. First part, one sample. Second part, multiple samples. Vice, back and forth, back and forth, back and forth. One multiple, one multiple, one multiple. So we did an example of the less than. There's the less than. I'm gonna do one of each because there's only three types. You got the less than. We already took care of the less than already. Now we're gonna do one that has greater than, and then we'll do an example that has in between. So you can see the differences between the three using this central limit theorem. Okay. So that's part B. Now, if you want to answer part C, you can answer it if you want. You don't have to on your homework, but part C, they want to know why can the central limit theorem be used in part B even though the sample size does not exceed 30? Why is it that we can use this central limit theorem? Does anyone know? It was one of the requirements. One of the requirements told us that we could use the central limit theorem, but why? Let's go back to our requirements. Our requirement said the problem must state that the distribution is normal and n has to be 30 or more samples. Well, this one only had 16, but did it say anywhere in the story that the distribution was normal? Who can spot it? Who can spot it? Where does it say that it is normally distributed? So you guys can find it.
Sir, what number are we doing? I left for a minute.
We're in number 5.
On C?
5C,
Okay.
Does it say anywhere that the problem is normally distributed?
What'd you
I
say?
see it. Let's see if you guys can see it too. Where do you see the term normally distributed at? I see it.
In the directions.
Yep. Right there. Normally distributed. It was hiding from you. Ah. Sorry, I won't laugh like that no more. But there it is. Whoop, there it is. Shakalaka chaka. So for part C, you would say, can use central limit theorem because it states that it is normally distributed. We can use the central limit theorem because the problem states that the pulse rates are normally distributed. Oh, let me switch it. Getting emotional. Okay, so we did a case that had less than in it. Let's do one that has greater than them. So I want you to pick me a problem in the book that has greater than in it. We just did 5. Is there one that has greater than? Is it 6, 7, or 8? We need to do one that has greater than in it.
Wait, sir, so for C, we can do it or we can't?
We can
Oh,
use the central limit.
oh, okay.
We can. As long as it says in the problem that it's normally distributed, then we can use the central limit. If it says it's skewed or not normal, you cannot.
So for that one, we don't have to figure out like any kind of numerical answer. We just have to put yes or no.
Correct.
Okay.
And we already did the calculation from part B. So
Oh, okay.
that's where we did the central limit for part B. All right, anyone want to pick me a problem after 5 that has a greater than? The word greater than in it? Which one has greater than on it? 6, 7, or 8? think, yeah, right. I think 6. Yeah, look at 6. Doesn't 6 have greater than in it? Yep. All right, 6. Let's do number 6. Okay. Excellent. Excellent. I see it too. I see it too. All right. Number 6. I think you're using the same instructions as we did number 5. That top part above 5, we're using the same item. So what is your mean and standard deviation for number 6?
Your mean is 74.0.
74.0. And your standard deviation is
12.5.
perfect. All right. Part A. How many samples are we conducting for part A for number 6?
Greater than 70.
No. How many samples are they conducting?
Oh, 1. I'm sorry.
1. That's right. They're doing 1. That's right. So we're gonna go ahead do the 1 sample. We're gonna do the 1 sample, right? Because it's 1. So that's why we're gonna do this thing. We're gonna do 1. So I already got my mean. I think we got my mean already. I got my mean. I got my standard deviation. Bam. Now I gotta find my probability. All right. So what is my probability statement for part A? The probability that X is what?
Greater than
Greater than
70.
70. Sorry, I'm making the sound of the heartbeat. Yeah, someone in my other class said, why is it that the heartbeats for women are higher than the men? Who can explain that? Why are women's heartbeats higher than men's?
Because the men stress us out.
Messed up.
All right. I mean,
Hey, no. Well, you ladies have to understand that we're under a lot of pressure. When we're watching a football game and we have a remote and a beer, that's hard. That's hard work because that's multitasking. You're watching, you're using the remote, and you're drinking. That's a lot of work, ladies. That's a lot of work. And then we have to sit. That's another issue. We have to breathe. And we have to listen. That's a lot of tasks. Just letting you know. I knew y'all were gonna say that men is the cause of y'all's increase in blood or pulse rates. I mean, we walk by, yeah, we're like, wow. All right, anyways, and we move on. All right. But it is a lot of work, people. It is watching TV, and especially the Cowboys, right? They lost. Idiots. They're back to the cow patties. Yeah. Next year. All right, so here we go. So here's my probability of X is greater than 70. And so now I'm going to convert. Again, ladies and gents, we're using the same thing that we did in 6.2. Same thing. Nothing has changed. It's the same old, same old. Plug it in. 70 minus 74.0 divided by 12.5. I did it in the wrong color. 12.5. It's supposed to be red. Oh, anyway, you guys see it. You see the red and black make red and black. 70 minus 74.0 divided by 12.5. Ooh, I got a negative 0.32. Is that correct? Is that what you guys got in your calculator? Negative 0.32?
Yes.
All right. And so now we're going to do probability of z greater than negative 0.32. Now this time it's greater than, so I have to look at the right area. The right. Yeah, put that number in to stat this, and you want the right area, not the white, the right. Not the wrong one, but the right one. No crying. There you go. Boom, 0.32, negative 0.32, and I want the right. All right, there it is. 0.6255. 0.6255, or if you want to write a percentage, 62.55%. So this is saying if you choose a woman at random, what's the probability that their heartbeat is above 70? Just for one individual female, the chances are that you will get one is 62.55%. That's a pretty high number, don't you think? High number. Of course, you can blame it on the guys, of course. Of course. Switch. Sorry. Right. So that's A. Kind of sound Canadian, right? A. Now let's do B. Okay, let's do part B. So part B. How many samples are they getting for part B? 6B. Let's look at 6B. 6B. If 25 adult females are randomly selected, find the probability that they have pulse rates with a mean greater than 70 beats per minute. How many samples are being conducted for part B? Is it one or is it multiple? Multiple, that's correct. Yeah, your N is 25, right? You're getting 25 female adults. So this is multiple samples. All right, so that means I have to use the right side of my handout. I'm doing the multiple sample one. I know your N is 25. I gotta find these two things. So I gotta find my mean of my means and my mean of my standard deviations. So my mu x bar is simply the same mu that we used in the previous part, which was 74.0. And I gotta find my sigma x bar. That formula was sigma, the original divided by the square root of n. My original mu was 12.5. And I'm going to divide it by the square root of n, which is 25. I know what the bottom is. I know what the bottom is. The bottom is 5. Is that correct, ladies and gents? The square root of 25 is 5. So 25 divided by 5 is 2.5. Now I got to find my probability for my problem. Okay, so since it's multiple, I'm going to put x bar. What are we trying to find the probability of? We're trying to find the probability that they have pulse rates with a mean greater than 70. Not 0, but oh no, I forgot my whiteout. Oh, I have to wing it. 70. You know, I forgot something. My mean is greater than 70. Let me switch it so y'all can see it. My mean is greater than 70. All right, let's convert. Okay, so I'm gonna plug in my 70 minus my 74.0, and I'm gonna divide it by 2.5. In a minute, you guys are going to see what really changed from part A to part B. What was the fundamental thing that changed only from doing part A and part B? All right, so let me subtract 70 minus 74.0 divided by 2.5. I got negative 1.6. Is that right? Negative 1.6. The right area. Right area. Plug it in. Negative 1.6 into stat disk. The answer. Negative 1.6. Evaluate. Right area. 94.52. (94.52%). That's supposed to be a 2, not a Q, like the Fidel, you know, package of Fidel, the Q and Q. You know what I'm talking about, right? The Q and Q. I love Fidel. Am I the only one that likes Fidel? You don't like Fidel, ma'am? What?
Oh no, Fideo's good. Oh my God,
Yeah.
Fideo is amazing. Some lime or
Mexican?
lemon in there and just, well, I like it a little bit soupy though.
That's
Some
true.
people like it thicker, so it just depends, I think, too.
Do you put comino in it?
Yeah, comino, my mom does it the old school way with molcajete, comino, garlic, and then she'll put tomato sauce and just water, and that's it.
I'm curious, who was the person who invented or discovered comino? Doesn't it smell like human, you know? Like someone didn't put deodorant. Like, why would you put it in food? Doesn't make sense. Hey, but it tastes good, doesn't it? Ignoring the smell. Human smells like human. But it's good. Some good stuff. I'm sorry, people out there. What are we talking about? We're talking about Mexican spaghetti. That's what fideo is, right? It's Mexican spaghetti. Some good stuff. Oh, we'll share recipes. One of these days. All right, good. All right, so there's part B. Now I want you guys to look at the setup. Look at what we did from part A. Oh, man, I wish I could put both of them on there. I guess I could. I could put them side by side. Okay. Look at the conversions from part. I have it reversed. Part A and part B. I see the 70s the same, right? But look at the formulas. What is the fundamental difference between the formulas? The numbers inside that resulted in our two different numbers. What was the only thing that changed from our conversion formulas? The only thing that changed. Because I see 70 minus 74 in both of them, right? But do you all see that the denominators is the only thing that changed? That's the only thing that changed. So the central limit theorem is really just adjusting the denominator of your conversion. That's what it's doing. Pretty much. The square rooting, yeah. And the square rooting too, yeah, the square rooting. Exactly. Taking the square root of your number of samples will affect that. Yeah, that's right. Very good. I want y'all to see that the connection between the two. All right, so we did a less than. We did an example of one sample less than, multiple samples less than. We did an example of one sample with greater than. We did an example of multiple samples with a greater than. We're missing one more. What are we missing? We are missing the
Between.
the in between. That's right. So we got to do an in between one. All right. Let me see. You guys get to pick one. Which one from our problems has in between? You pick 7 or 8. Which one would you like? Oh, I don't want 7, man. Try again. I'm kidding. No, I would do 7. All right, fine. Because it's on your homework, right? Fine. 7 it is. Ah. All right, here we go. 7. All right, so 7. 7 uses the same thing that we did before. Our mean is 74.0. Our standard deviation is 12.5. And how many samples are we conducting for part A for number 7? To me, it looks like 1. Sorry, Haley, I beat you to it. She got mad. 5. You get credit. All right, 1 sample. All right, so I already found my mean. I found my standard deviation. I just need to write down my probability. I think number 7A says find the probability that her pulse rate is between 72 beats per minute and 76. Okay, so I have to put 72 first, less than X, less than 76. That's how you do an in between. 72 and 76. This is how you do it in between. Although I had students reverse it. No, you always put the smaller number on the left, bigger number on the right. It's like a number line. Numbers on the left are smaller than the ones on the right. Convert. Okay, we have to convert. Oh, I have to do the formula twice, people. So I have to do Z equals X minus mu over sigma. I got to do it for the 72. And I have to do it for the 76. So 72 minus 74.0 divided by 12.5. This is our usual one. We don't have to do any modifications on this one. I divide by the square root of n because we're doing 1 sample. Divided by 12.5. We're going to calculate it, both of them. Negative, oh, what is he eating? One of my colleagues, he nuked something in the microwave. I'm like, really? You're gonna eat here in the office? I don't know about that. That's dangerous. I think he was eating a hot pocket. Yeah, that should be all right. Not nutritious, but hey. Wait a minute. Whoa. Wait a minute. I think I messed up. I think this is supposed to be a 76. Am I right? Second one's supposed to be 76. I knew I messed up. 76. That should be a 76. Big boo-boo. Oh, it's positive. Oh, I got a negative and a positive. Interesting. Interesting. 1 positive, 1 negative. Okay, now this one, for the in-between, I have to do Beyonce's. To the left, to the left. Left, left. So I'm gonna look up the area of negative 0.16. And then I'm gonna subtract the area. Oh, positive. This one should be positive. 0.16, and then this one should be the area of the negative. plug in the positive first, then subtract the negative. Okay. Minuto. Okay, so let me look up the positive first, and then we'll look up the negative, and we're gonna subtract them. All right, let's see. Okay, let's look at the positive one. 0.16 left, 56.36. $56.36. Now I gotta put a negative. $43.64. And I'm gonna subtract it. 56.36 minus 43.64. $12.72. You guys can check the answer in the back. Just to double check. Is it correct? Number 7. Bam. Ooh, yep. 12.72. Yeah, we did the technical version of it. Yep. 12.72. There's part A. Now I'm gonna do part B. Part B. So part B. Y'all all right? Okay, quiet. Y'all quiet for him. That's scary. Not a good thing when you're quiet. You guys are not stressed yet, right? I'm not stressed. That's all that matters. 7B. If 4 adult females are randomly selected, find the probability that they have pulse rates with a mean between 72 beats per minute and 76. How many people are we conducting? Is it one or is it multiple? For part B, 7B. This is multiple. You're dealing with 4, right? 4 people? Multiple sample. This is a multiple sample column. So 4 is your N. And So if you're doing multiple samples, we gotta find mu x bar and we gotta find sigma x bar. So my mu x bar is my mu, which was 74. My average of my standard deviations was sigma over the square root of n. I believe this was 12.5 divided by the square root of 4. I think the square root of 4 is 2. Is that correct? It's 2. 2. 2. 2. 2. Uh-oh, Savannah got mad. 6.25. And I believe that the probability was identical. I think it was 72 less than, now it's x bar less than 76. I think that's what it had on the book. And we're going to convert. This is taking long because we have to do two versions, one with one sample and the other one is multiple. The other exercises that we do, I think you're just going to do the multiple version of it. I think. I'm not too sure. We'll have to try it out. So convert. We're going to do my formula. 72 minus 74 divided by 6.25. And the other one is 76. O divided by 6.25. I'm gonna calculate it. Let us calculate it. 72 minus 76, 74, 74, 72 minus 74 divided by 6.25. Negative 0.32. And the other one is positive 32, I think. Yeah, it is. It is positive 0.32. No yawning. Are we doing it in between? And it's to the left, to the left. Beyonce song. Area of 0.32 minus the area of negative 0.32. And I have to put that in my stat disk and find each one individually. Left, left, left of the positive 0.32 and left of the negative 0.32. And then we subtract. You guys are making me sleepy stuff. I need caffeine. No, hombre. Okay, I'm gonna put 0.32 positive first. Left area is 6255. 0.6255 minus, now I gotta put a negative. I think someone make, I'd make this other, that sounds good. 37.45. 37.45. 37.45. And I'm going to subtract. Fifty-two 55 minus 0.37. 21, 25, 10. 25, 10. $25.10 beer cent. You're probably wondering why is the percentage so low? Well, think about it. What's the probability that you're gonna find 4 females? 4 females, just at random. And the probability that all 4 of those females have heartbeats between 72 and 76. It's gonna be kind of low to find exactly 4 of them that have heartbeats between 72 and 76. It's small, yeah, because you have to find 4 of them that are between them, and you're picking up at random. That's going to be kind of low to find 4 of them with that. Okay. Did anyone in here, when y'all took your driving test, how many of y'all failed the first time you took the driving test? Anyone? Oh no, Haley, you failed it twice. Damn. Friday was not a good day. I hit the pole day. No, the pole hit you. You didn't hit the pole, the pole. Oh, the parallel park, dang it, man. So my son went to go get his driving test Friday, right? He nailed the parallel parking. Bam! I was like, yeah, baby, yeah. Right? So they took him around the neighborhood, right? Ooh. So he was doing great, man, great. And then the instructor told him, all right, go ahead and let's go back to the DPS, and then I'll write up the report, right? So they go, and so there's 2 lanes, you have the left lane and right lane, and the DPS is in the right lane. Well, my son was in the left lane, and all of a sudden he just stopped right there at the entrance of the DPS on the left lane, put his signal light, and then turned and cut right in front of the right lane and went into the DPS. And the instructor goes, "Are you serious? Did you just do that?" My son was like, "Yeah, why? You failed. You failed." Oh, I was sad. So yeah, he has to go back Tuesday. I mean, he had everything. He had it in the bag. It was like you could just taste victory right there, and then that happened. Like, and everyone before him failed. All the kids failed. They didn't do the parallel parking right. They didn't put their signal light, and they're all crying. They're all crying because they failed. My son's like, whatever. Dang it, son of a biscuit. No, yeah, he was like that. Oh no, you were driving a truck. Dang. I hope it wasn't one of those 18-wheelers, Haley. It's just saying, one of those semis. That would be bad. You're not allowed to take what? You're not allowed to teach him to drive it. I know. Dang it, man.
When I was
Wow.
driving in the neighborhood, like during my driver test, there was someone working on their car and their body was all out on the street. Like I was about to run that guy over. Like, I don't care. I want to pass this test.
and they marked you wrong. They're like, go back to GPS.
Yeah. And then I was going back, and then there's a big old garbage truck was backing up. I was like, "Do you not see me? I'm trying to go." But yeah,
You're
it was
like,
one of
really?
obstacle
You're like,
courses.
what's the probability that all those things happen when you're taking your driving test?
I know. And then and then when I went to go to the DPS back, there's some people jaywalking. I was like,
No.
no, but definitely gonna hit them.
Yeah, next time tell the instructor, do I get points for running over them? Like extra points, like extra credit?
For real. No, but he had lunch after me, so he was in a good mood.
Yeah, well, I had when I took mine, I had an actual DPS officer in my car, and he put his drink, his coffee, on the dashboard, and he told me this. He said, if that coffee cup falls over, you fail. I'm like, okay.
Are you for real?
Yeah.
Oh
He
my
put his coffee cup on there. That thing spills, you fail. No pressure.
That's
Right.
scary.
No pressure. Yeah. That's why I go 100 miles an hour on the expressway now. Now you understand why. Good times. I don't know these TPS people. Then you go and and then they ask you for things that you don't even have at there. Like I brought his birth certificate, his passport. I brought baby teeth, hair sample. What else? His first booty. What else? Yeah, I brought all those in case, you never know.
Toothbrush.
His dog, his cat.
His
Brought
socks.
everything.
His socks.
I brought everything. Well, you never know. You never know. All right. So now you guys the just. So multiple samples. That's the main thing about 6-4 is the multiple samples. You're gonna be doing this part on the rest of the questions on 6-4. So you guys gonna pick for me an example problem that we can do together. And okay, so let me give you choices. Do you want to do elevator safety? Do you want to do Mensa? Sorry. You want to do water taxi safety? That's terrible. Southwest Airlines seats, redesign of ejection seats. Wouldn't that be cool if you had that in your car? An ejection seat for your passenger. Not if you're married. Or doorway heights. Which one would you like? We're trying to do an odd one. What would you like? Which one interests y'all? Which one caught your eye? The elevator, the Mensa, water taxi safety, like we really need a water taxi safety in San Antonio. Southwest Airlines or redesign of ejection seats. Which one interests you all? $17. Redesign of ejection seats. Ooh, that's a good one. All right, that's a good one. All right, so when women were finally allowed to become pilots of fighter jets, engineers needed to redesign the ejection seats because they had been originally designed for men only. The ACES 2 ejection seats were designed for men weighing between 140 pounds and 211 pounds. Man, I haven't weighed 140 since I was in kindergarten. All right, too much information. Because it's steroids, of course. Weights of women are now normally distributed with a mean of 171 pounds and a standard deviation of 46 pounds. All right. Boom. All right. So, right, just not me reading the problem yet, but what are we told at the very beginning of this problem? What are we given for 17? What do we know so far? So I know my mean and my standard deviation. What's your mean and standard deviation? For 17. Correct. 171 and 46. All right. Letter A. If one woman is randomly selected, find the probability that her weight is between 140 and 211. Is this a multiple or is this a one sample problem? It's a one sample. Bam, very good. All right, so I already got my mean. I got my standard deviation. I just need to find my probability. Oh, this one is also between, isn't it? Yep. 140 and 211. 140 and 211. Let's see. Let's see what is the probability that these ladies are gonna, these jets are actually designed for specific people. Like it's a personal fitting for the jet. Like that jet is yours. Like if you are a pilot, that's your airplane. Isn't that cool? It's like yours. Mind boggling. All right, anyways. So Z equals, I gotta do it for the 140. 71 divided by 46. I gotta do it for the 140. And I gotta do it for the 211. Crooked. Why is it crooked? Like a politician. 140. Divided by 46. Oh, ooh, I'm gonna have to round this one. This one ended up giving me negative 0.673913043, something like that. So I'm gonna have to cut it off to 2. So this ends up being negative 0.67. Yeah. And I think the other one, I hope it's positive. Hopefully it's the same number, but positive. Hope. Nope. It came up different. Eight, 6, 9, 5, 6, 5, 2, 1, 7. I need 3, so that would be a 2 places. 87. Yeah. 80. Wait, I made the boxes too big. I'm gonna find the probability of negative 0.67. I didn't put convert. Left. So area of 0.87 minus area negative 0.67. And I gotta find both of those numbers on the stat disk on my left. It's supposed to be a 6. It's just that my paper got there. Cut off. It's supposed to be an 8. No, hombre. All right, 0.87, 8079 minus negative 0.67, 2514. $80.79 and $25.14. Oh, I forgot the decimal. Antonio Texas. 55.65. .65%. So 55.65% of the females can fit in the females can fit in the aircraft. All right, ladies, what do y'all think? Is this a sufficient percentage for women on the airplane? Are you happy? Is that a good percentage of women who can fit in the airplanes? Yay or nay? Or are they gonna have to redesign it to fit the females in the planes? What do you think? I think 55 is too low. I think they need to redesign it. I think. Right, because that's saying that all the females are gonna fit. Like 50%. 50% will be able to have their own plane, right? Us Texas ain't built small. You said Texas with an accent. Texas, a Texas girl. That's right. I reckon. So, okay. All right. So that's I think that's too low. But then again, the planes are designed specifically for personalized plane. But they disagree. The government disagrees. They say, no, 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 this is right. Because if you answer part B, if 25 different women are randomly selected, find the probability that their mean weight is between 140 and 211. So you're just picking 25 ladies at random. What's the probability that their weights are going to be between 140 and 211? So notice this one. This one's a multiple sample. So my N is 25, multiple sample. Right? And so I got to find my mu X bar and my sigma X bar. And so my mu X bar is my mu. My mean of my standard deviation is sigma over the square root of N. Right? And so my mu X bar is my mean. What was my original mean? My original mean was 171. Right? My sigma is 46, but I have to divide that by the square root of 25. So let's see, 46 divided by 5. What is 46 divided by 5? 9.2. 9.2. And so they want you to find the probability now that the mean is between 140 and 171. Their mean averages of those 25 are between 140 and 171. Let's see if that matters. Okay, so I'm gonna convert. I didn't put convert in the other one, did I? Oh, yeah, I did. Convert. So Z equals 140 minus 171 over 9.2. And Z equals 140 minus 171. Oh, I already did 171. Whoa, I messed up. Oh, it's 211. 211. 211. Yeah, that should have been, I messed up. Z equals 211 minus 171. There you go. Yeah, that's better. Okay, now let's calculate it. 140 minus 171 divided by 9.2. Ooh. Negative 3.37 was my answer when I rounded off to two places. The other one, $4.35. If I rounded out to two places behind the decimal, I got 4.35. So now I gotta do my probability of negative 3.37. Z 3.35. That's left. So area 4.35 minus the area of negative 3.37. I'm gonna have to type those in. That disk. $35. Ooh, 9999. Oh, I gotta round that one to through. I gotta round that one to 4 places. Look at that. Oh, that's 1, isn't it? That's 1. Right? The fourth number increases the fifth number increases the fourth 9 to 10 and it carries over. So it becomes 1. Ah, weird. Never had that before. And I got to put negative 3.37. Left is 0.0004. 0.0004. So what's 1 minus 0.004? $99. 99.96% of the females would have an average mean weight between 140 and 211. Whereas the other one, you were just taking one individual person who came in and weighed themselves. But here, it's the average of the females that come in, 25 of them. So yeah, the higher the number, right? Because now you're having more people come in, 25. You're taking the average of their weights, and pretty much they would fall probably in between 140 and 211 pounds. Yeah. So the forces are going to go with that. So I'm just noticing right now, all of the problems require you to do one sample and then multiple samples. I just noticed that. So you'll have to do one sample and a multiple. Didn't know that. Good to know. Good practice. Good practice. My hand hurts, but that's right. my hands all dirty. Look at that. It's from last week. I didn't think about it. No, it's not brown. It's ink. That's gross. No. It's Inkitna Costra. Did I pronounce it right? Costra. Costra. But yeah, you'll have to do one of each on the exercise. It's good practice. And the reason why it's good practice is so that way you won't forget how to do 6.2. It's kind of like a refresher. And then the new stuff is the part B. There's the part A. This is what we did in 6.2. And then that's the new stuff. 6.7.3, 6.3, 6, whatever. That's good practice. So practice these, people. Practice these. I think there's going to be like 2 of them on your next test. There's 2 of them that require you to do multiple samples. So that you know. Giving you heads up.
Sir, I have a question.
Uh-huh.
On the final, is it gonna be like over everything from chapter 1 to where we finish, or is it just gonna be on the last sections that we cover for the last chapters?
Everything since you learned from kindergarten, ma'am.
Oh, shit.
Everything. It's cumulative.
That's not good.
You
I'm gonna fail.
remember eating-
I'll see you
remember
next semester.
Do you remember eating mocos? That's gonna be in the test. Did you ever eat Lucas? Do you remember that?
Yes. The salt con limon.
Yeah, okay. That now back then we were eating all that stuff, right? Did you know that really ruined our teeth?
Yes.
The enamel?
I have to get veneers, so I'm gonna get them like next next month
know.
for real.
I know. You know how I know? Because we went to my high school reunion, and all my friends didn't have teeth, and they were all bald. And that's
think-
just the cheerleaders. I'm kidding.
I think that's genetics.
The cheerleaders, yeah. What is he does? Yeah, they don't have teeth. What is he does? Where are my dentures?
Now it's good because they wear a mask.
Yeah, you can't
There
tell.
you go. Nobody
There you
will know.
go. It's a win-win. So eat as many limon and
Salt con limon.
oh, yeah, we used to eat Kool-Aid concentrated from the package.
You eat
like that.
we used to put sugar and salt in the Kool-Aid and then shake it up.
Ah, bad. That's bad for your
Yeah.
intestines.
You know, I
My
did
mom-
that like whenever I was still at the plant and I was pregnant with my son. He's 4 now, but whenever I would crave that. And so we had to wear gloves, right? When we're on the line, and I was just being a cochina. I would take off my gloves and then I would dip my finger in the Kool-Aid. And then everybody was like, we couldn't tell because your fingers are all red and your mouth is all red. And it was a mess. I couldn't hide it.
That's right. Did it taste like Toyota?
Gross.
Tasted like Toyota. Delicious. Ah, the good old days, people. Ah, you youth. Lucas, come on. Really? Ah, gross. I can't do that stuff. Ah, can't stand it. Oh, Lucas and me. Lucas. All right, so there's your 6.4 lesson. So you should be right. I think you only have like 3 more questions to do because I did all of them already for y'all. All right. So we're done with 6. Absolutely done with 6. We only need 2 more sections for 7, and then that's it. We're ready for the next exam. Now, this one you guys are gonna love these. All right. So I'm gonna cut the. Usually I show my students the all of the background information of what we're actually doing. So I'm just going to show you the nuts and bolts of how to do this topic. All right, so this topic in 7, because we're only doing 7.1 and 7.2. And man, I really need to send y'all the link for it. The notes. Hold on. I'm gonna have to. Let me see. Yeah, I'm gonna have to send this to y'all. Let me download it. Hold on. I need to send you 7. Then I'll tell you what we're gonna do. How many of y'all voted for? Y'all voted for the president last year. How many of y'all voted? Everyone vote? Right. So you ever wonder how in the world, you vote on election day, right? And yet the media can get the data so quick. How do they project? How do they project who won and who didn't? Right? So fast. So I'm gonna show y'all what do they do? What does everyone do before? Because it's a long process for you to count what? There's a 250 million people in the United States, I think, or there's more. I don't know. There might be more. But how are they able to count all those votes in days or like real quick? So we do it by estimating. That's how it's done. That's how it's always done. It's by estimating. And so what they'll do is in San Antonio, what they'll do is they'll pick a precinct which contain the most number of people who voted. Usually it's the people in the King Williams area, which is straight downtown, because that's mostly older people. And they'll vote, they'll use that as the source to use as a sample to kind of more or less guess what the whole overall San Antonio voted for. So let me see, I think I got it. Let me send it to y'all. Hold on. Okay, I think I sent it to you. Hopefully it worked. All right, maybe you got it. I put in the chat. The
Is it
note.
like what is it called? Like an algorithm or something like that? Is that what they do? Or it's different?
It's kind of like an algorithm what they do. And every year they do a survey, and they, you know how they do the census and all that.
Yeah.
And they kind of more or less find out which zip code had the most number of votes, and they'll use that sample to kind of use that as an overall projection of who won. It's usually King Williams people that they use. They're older people and they love to vote. That's what they do. So they use that as a base, and it's 50-50. It's and they also look at the code, and they kind of measure like they don't want it to be biased, right? They don't want a lot of Republicans, a lot of Democrats, a lot of independents. So that precinct has a variety, and they use that as the base for estimating. So that's what they do. So it's the name of the section is called Estimating a Population Proportion. Put it on the screen. Estimating a population proportion. Now, the thing is proportion. You're like, well, what the heck is proportion? All right, so a proportion can be a fraction. It can be a decimal, or it can be a percentage. So, for example, a fraction could be 2/5. Right? Y'all know what would 2/5 be in decimal format? What would 2/5 be in decimal format? How would you convert 2/5 to a decimal? Yeah, you divide, right? divide 2 by 5, and you should get 0.4, right? 0.4? 0.4. Percentage, this would be 40%. So the trick of this is you're estimating the population proportion using a sample. That's the trick. So let's say I think next year we're going to vote for governor. Right? We're voting for governor next year. All right, who are our candidates? Who is running for governor in the state of Texas? All right, so I think it was Matthew McCon. What's his name? The actor. What's his name?
McConaughey.
Yeah. How do you pronounce? How do you spell his last name?
Mm.
Oh, I got it. Matthew. He got a freaking he something like that. Yeah, and I think Beto is running too. Beto, you know who Beto is, right? Beto Rourke is running for governor, and I believe Willie Nelson is running. And should we put a Kardashian, even though she's not in Texas? We'll put a Kardashian. We'll put Kim Kardashian. Why not? Kim Kardashian. Who else do we put? Now we got to put Dak Prescott, right? Dak Prescott. That's what his last name. Who else? Who else is running for? Dang it! Who else do we put? You know what? We should put. I know. We forgot about what's her name? The one from Alaska. She ran for president. What's her name? What's her name? I forgot her name. She's in Alaska. What's her name? Golly. Oh, what's her name? Sarah Palin. I couldn't remember. There we go. Sarah Palin.
Sir Haley said Kanye.
Kanye. Well, okay.
Easy.
Well, Kanye. Yeah. I would vote for him. Shoot. Kanye West. We didn't put a Hispanic. What about George
I think
Lopez?
it should be me and Haley because if we could win against these people.
Okay, we'll put your write-ins. Yeah, we'll put, all right.
One
Erica. And Haley. We'll put Hale yes. For Haley. There we go. All right, so who are we gonna vote for? Here we go. All right, hey. Mom's the word, right? We'll make it an anonymous, right? Who are we gonna vote for? Man, this is a tough call. Vote for me, please. What's the incentive, ma'am? Is there any cash? I'm gonna go with Willie Nelson. Okay.
That's messed up, sir.
I know. I don't know. Maybe I'll give half to Erica, number one. Right? Dang, that's a lot of people to vote for. I don't know. Man. Okay, so here we go. So on TV, right? On TV, they give you the percentages. We'll put 4%, Beto 3, Willie Nelson 2, Kim 0.001. No, actually no. Kim Kardashian would have 0 plus. It's messed up. Dak 1%, Sarah Palin 1%, Kanye, all right, 2 baby. George Lopez, no, but forget it. And then, all right, then Erica and Haley. Dang it, it's a close call. It is a close call. Let's see who is going to. Let's see. Let me look at the records. All right. I'm looking at their criminal background check. Let's see. Oh no, that's not good. 43% each of them. God, look at that. Dang it. Oh, runoff. They have to do an obstacle course for the runoff. They'll have to drink the water from the pond from NVC, and whoever survives wins. How's that? Hijo. So they'll, that day. So how do they count on TV? How do they count the tallies so quick? Well, what they do is, they have early voting, right? So they look at the early voting first, and they kind of project what it is. So they go and get the results from that place in the King Williams area, and they'll count the votes. Oh, look at that. Erica and Haley have the most votes. Boom, and they'll project it. But at the very bottom of the screen, and they do it quick. They do it super quick. On the bottom of the screen, you'll see this little wording, this really fine small print. And it says margin of error. And it'll have a plus or a minus on there. That right there is what they use to project who is going to win. Again, it's not finalized until every vote is counted. Sometimes it takes a long while for a vote, and they can't rely on projections, so they have to wait. So they'll say, yeah, this is what we project that is going to win. But they don't tell you, hey, they use a sample to get these numbers. And you'll see it. You'll see all the positions, and you'll see that little fine print on the bottom of the screen. So I'm going to show you all how they get these projection numbers so quick. And that's what 7-1 is. But there's going to be a lot of little details that I have to show you. Yeah, show your son about the votes. Yeah, show him. Look at that. One Erica and Haley is running for. That's her slogan. One. One is not a lonely number. There you go. That's your slogan. All right, so let's go through the handout that I gave you all. So the handout that I gave you all, oh man, I didn't see it. Well, I do have it. Where is it? Yeah, I do have it. Hold on. All right, so the front page. The front page of the handout that I gave y'all is pretty much if you want to do it by hand. If we want to compute the confidence intervals or the sample size, I'm giving you all the option to do it the long way. I would not recommend it. Why? Because it's too freaking confusing. So that's the long way of doing it. We will do these two by hand when we get to it, but not right now. So if you want to do it by hand, by all means, you'll have to read the book. You'll have to read the book, and it'll tell you how to do it. But the main thing is this word right there. Best point estimate. Okay, that number right there, that thing right there. That's your first definition of many. What is a best point estimate? Best point estimate. All right, so best point estimate is is a single value used to estimate a population parameter. The sample proportion, and we use a symbol. It's a P with a little sombrero on the top. It's a party hat. Sample proportion, we use a P hat, is the best point estimate of the population proportion. And we use just a regular lowercase p. So how do we distinguish? Sample proportion uses a p with a hat. Population proportion, they use just a regular little p. Yeah, little p. So the best point estimate formula is, you guys remember in probability, it was parts over total. X over N. Parts over total. And it says here on the paper, do not round. Never round your best point estimate. Parts over total. Okay. So in order for us to get the actual percentages, again, they're estimates. They're not in stone. They're just estimates. What we do is we create these things called confidence intervals. Confidence intervals. Right. So what are confidence intervals? Confidence intervals is a range of values used to estimate the true value of a population parameter. And so I'll give you guys an example of what a confidence interval looks like. And that's what we're gonna, these intervals won't give us, it won't give us the direct Erica and Haley numbers. It will give you a range of it. Now, in order for you to get the exact numbers, you are going to have to get the sample and count every vote and determine that those are actually accurate. Or if you want the bigger picture, you want to go ahead and interview or look at all the votes from San Antonio and get that actual number. But this is what an interval looks like. So let's say that, let's see, what do we do? Where should we go? Where should we go and get the data from? All right, so let's say that we go to, shall we go to the south side and get the votes to see whether or not Erica and Haley won? Yeah, we'll go to the Traders Village area, Marbach, over there in that area. Go to Marbach. I don't know how to spell Marbach area. South side, of course. To see who voted. Erica, number 1. Or Haley. Am I running out of time? Oh, I can run out of time. Son of a biscuit. You didn't tell me I ran out of time? Damn it. Why should you tell me? That's why I'm all ping. Like, what the heck? Great. I kept y'all overtime. We're chilling. Yo, what you really want to know who voted for y'all? I'm gonna keep you in suspense. I'm gonna go bribe them. I'm gonna tell you later. Who's gonna win? Who's gonna win? We don't know. I'll let you know. I'm gonna do a coin toss and see. But I'll show you on Wednesday. I'll show you what an interval actually looks like, and then I'll show you the other little things that go along with it to create this interval. And then I'll show you how to do it in StatDisk. And in StatDisk, all you do in StatDisk is you just gotta find some numbers and you plug it in, and it'll give you the confidence interval automatically. Boom, like that, or bam, like that. But you have to wait till Wednesday. Bueno, okay. Bueno, bye.
Bye, sir.
Good
Bye.
day.
Bueno, bye. Bye. We'll see you Wednesday. Bye. Yes, I will release the grades tonight. Yes, I will. I'll release them. No, I don't have my papers. I'm at home. I'm at work. I left my flash drive. I was looking for my flash drive that had the grades, and I left them at home. I'm sorry. We'll just put an F for yours. Is that all right? We'll put an F. Yeah, you'll be all right. You failed, yeah. Yeah, but you may have won the election. We don't know. We'll see. I'll put them up tonight. What am I? Bye, guys. Bye.